Hello, my name is Amy Edelson, and today we're going to be talking about the flame test. As a child, I remember sitting in the grass in the beginning of July, watching as fireworks lit up the sky, and thinking, how do they make all these colors? One of my favorite experiments from chemistry is the flame test. It's applicable for everyone from a geologist to a forensic scientist. The flame test is a great way to represent how different elements have different flame colors, and this is because their electrons have different allowed energy levels. According to the Bohr model, when you heat an atom, once a specific wavelength hits the electron, then the electron enters an excited state and jumps up to the next energy level. When the electron drops a level, it emits a quantum of energy. This wavelength of light depends on the difference in the energy levels. Whether or not we can see the color depends on if the wavelength is in the visible light spectrum. Each element has its own characteristic of set energy levels. The emission of light, shown in the flame test, is also known as chemiluminescence. The flame test shows this in a more short-term reaction. This can also be shown in a more long-term reaction when the light is emitted slowly over a long period of time. The technical name for this is glow-in-the-dark. The flame test can be used to test to see what colors the chemicals will produce for a firework. For example, if you see purple, it's very likely that there's potassium in it. Or if you see orange, it's very likely that there's sodium. Or red, it's probably either lithium or strontium. Or green is usually copper. Another example of a use of the flame test would be flare guns, or more specifically, the flares. The flares need to be a bright, unnatural color so people can easily spot them. Similar to a firework, a combination of chemicals are used to obtain a specific color in flares. The main ingredient in a flare is strontium nitrate, which burns bright red, potassium perchlorate, a powerful oxidizer which makes the strontium burn quickly, and magnesium, which burns very brightly. The only downside is perchlorates, which contain chlorine, aren't very environmentally friendly. So organizations like the US Navy have been working hard to develop a perchlorate-free flare using copper, which will create a green color, and polyvinyl chloride to enhance the color. While most would think that a straightforward high school chemistry lab isn't very important, in reality, the flame test has many real-world applications for something as old as fireworks and as significant as flares. And if nothing else, for the little girl watching the night sky, it sparked a lifelong love of chemistry. Thank you for watching.